Okay, so in this lesson we're going to look at laws of exponents with application problems. So we're going to take what we did in the previous lesson and now we're going to apply it to a word problem and see how they might use a shape or just a word problem in general to get us to use law of exponents. So again, we are still simplifying numerical algebraic expressions using the law of exponents to include integer and rational exponents. So the first kind of application problem we have is we want to determine the area of the rectangle below. And you can see they've given us our length and our width, and we're still going to follow those same order of operation steps that we used in the previous lesson. We're going to start with power to a power, which is going to tell us we need to multiply. If we need to multiply, then we're going to really add the exponents, and then we're going to go into looking at our quotient, zero, and negative exponents to kind of clean up our answer. All right, so the first thing I've got to do is they have asked me to find the area of the rectangle. So if you don't remember your formulas, there is a formula chart posted to Canvas, and the area of a rectangle, if you remember, is length times width. Okay, so I'm going to write that here. Area is equal to length times width. Well, what did they use for the length? They used 10 a to the 6th b to the 8th power. And I'm going to go ahead and write b as a capital B so it doesn't look like my 6. And then now I'm going to plug in my width, which is 6 a to the power of 2 b to the power of 3. Okay, so now it really is, if I cover up this a equals, it really just is looking like one of the problems that we had on our lesson yesterday. So again, I do not have power to a power rule because I'm not seeing any parentheses with exponents inside and outside. So now I'm just going to multiply, take care of multiplication, which tells me I'm really just adding my exponents. So just like before, I'm going to identify all of my bases. So I take care of my numbers first. My next base is an A, and then I also have a B that I need to take care of. Okay, and we're going to do exactly what we did yesterday. So we're going to take care of our first base. So we're going to say A. And remember, when we are multiplying, we're really going to add our exponents. So I'm going to add 6 and 2 to get 8. All right, my next base is B. And again, since we are multiplying, we're really going to add those exponents. So I've got 8 plus 3, 11. And now I'm going to do exactly what I should do. If the A's and B's were gone, I would have a multiplication problem. So 10 times 6 is 60. So my area expression that I would say, my area is equal to 60 times the value of A to the 8th power times the value of B to the 11th power. I'm not going to get a number answer for my area yet because, again, I don't have an answer for A or B. I just wanted to write my area in a simplified way so that I had a single A base with a single exponent and I had a single base of B with a single exponent. So this is my final answer. I don't see a quotient, so I don't need to subtract my exponents. I don't have zero or negative exponents. This is my final answer. All right, let's look at the next one. So we're going to determine the area of the right triangle. Again, area of a right triangle. And if you remember, your area of a triangle is base times height, and you're going to divide all of that by 2, and that's going to give me the area. Okay, so I'm going to fill in what I know. So I'm going to make a fraction bar here. Okay, I've got a base, B, so I've got 4x to the 8th, y to the 4th, because that's the base, the bottom side of my triangle, and my height, how tall my triangle is this expression right here, 8 times x to the 5th times y to the 3rd. So I'm going to say 8 times x to the 5th, y to the 3rd, and I've got to extend my fraction bar out, and then all of that has to be divided by 2 so that I have the correct area formula. All right, so now I'm going to say the area is equal to, okay, now I'm going to start my order of operations again, power to a power rule. I don't see any exponents inside or outside of parentheses, so I do not have a power to a power rule. Now I'm going to check for multiplication, and I see I have multiplication right there. So now I know I need to add with my exponents. Okay, so again, we're going to identify all of our bases, I have a 4 and an 8, so I have two bases that are numbers. I see an x here and here, and then I have a base of y here and here. Okay, so here's what we're going to do. So now we're going to take our x's, so I'm going to draw in my fraction bar. We're going to take care of our bases of x first. And when we multiply, what are we doing again with our exponents? We are adding, so it's going to be to the 13th. And my next base is y. All right, again, what operation will we be using on our exponents if we are multiplying? We are adding. So 4 plus 3 is 7. And now I've got to take care of my bases. Well, if my x's and y's disappeared, I would have 4 times 8, which is 32. And then remember, we're dividing all of that by 2. So the only thing that I can divide by 2 is the 32. So I can do that in my calculator. So 32 divided by 2 is 16. So I can go ahead and complete that division here, and then my division by 2 disappears and goes away. So my area is really equal to 16 times x to the 13th power y to the 7th power. And that is my final answer for my area. Again, I'm not going to get a final number answer because I do not have an answer for x or for y. All right, let's look at the next one. Determine the surface area of the cube. Okay, so if I look at my formula chart, which I have beside me, I'm going to see that the surface area, I'm going to abbreviate it, S dot A, is equal to 6 times side squared. Okay, so I've got to know how long my cube is, one of its sides, and they told me it's 2 times a to the third times b squared times c to the fourth. All right, so I'm going to find the surface area. So it's going to be 6, and then I'm going to replace s with whatever my side is, and this is the expression they are using for my side. So I'm going to replace s with 2 times a to the third times b squared times c to the fourth. And all of that is going to be raised to a power of 2. All right, so again, we're going to go back through our order of operations. Power to power. I see that because I have exponents inside and outside of parentheses, so that's telling me I have to apply the power rule. Okay, so I've got a 2. I have a base of a. I have a base of b. And then I have a third base, C. So really, if I include my number base, I really have 4 bases here that I've got to make sure that they all get taken care of to a power of 2. So I want to make sure all of my bases have an exponent, and the only one that I see is missing one is my 2. So I'm going to make that 2 to the power of 1, because remember from yesterday's lesson, if you don't see an exponent, it's always a 1. All right, so we are going to follow our arrows. Power to power means we are going to multiply our exponents. And if you have a number inside of parentheses, you got to continue to have it in the parentheses. And now I'm going to multiply my exponents. So I'm going to get 2. My next base is a. So I'm going to multiply. 3 times 2 is 6. My next base is b. So I'm going to say 2 times 2 is 4. And my final base is C, and 4 times 2 is 8. Okay, so that takes care of my power rule. But if you notice, look, I have this 6. I am multiplying whatever I get raised to a power 2. All of that gets multiplied by 6. So I've got to show multiplication. All of this is going to get multiplied by 6 in order for me to calculate my surface area. So here's what I'm going to do. Okay, well, if all of my variables went away, could I not in my calculator see what 6 times 2 to the power of 2 is? Move my paper up a little bit. I absolutely could. So that's exactly what we're going to do. 6 times 2 to the power of 2, and I got 24. And since we don't have any multiple A, bases of A, any multiple bases of B or bases with C, I don't have anything to add to those exponents. So my final answer is going to be 24 times a to the 6th power times b to the 4th power times c to the 8th power. And then I'm going to keep going through all of my rest of my laws of exponents to make sure I've taken care of anything. I don't see a quotient anymore, so we're not going to subtract the exponents. I'm going to double check. I do not see any 0, and I do not see any negative exponents, so this is my final answer. All right, here's another example. Determine the volume of the rectangular prism below. Okay, volume for a box, a prism, if it's rectangular, it has to be rectangular, is length times width times height. Okay, so we're just going to fill in the length, 3xy squared. Width, how deep it is if it's three-dimensional shape, so that's going to be x to the 3rd y.